All right, so here we're going to look at reduction formulas. And so notice the expression below on the right side here, once we get this, still contains an integral, but the exponent of x has been reduced by 1. So here we start with u to the n, then we have u to the u to the n minus 1. Now, we saw this in 13.3 when we were doing integration by parts. We started with an x squared e to the 2x, then we got down to x and then e to the 2x, and then we had to go another time and do another substitution in the by parts, and then we got down to the final thing, and then we ended up with, 4 parts at the end. And so that's kind of what we're talking about here. We're trying to doing reduction formulas to help us solve an integral goal, and we're just repeatedly redoing that until we can actually obtain a final solution obtained. All right, so that starts here. So here's what we have. This one, this is x squared e to the 3x. We did 2x for our last assignment. And so here we have this. We pull this down, and so now we just have x e to the 3x. Well, that still is in the form of this, and so we can use that whole thing again and go through it all one more time. And now with e to the 3x, we can actually simplify that, and that's just 1/3 e to the 3x. And so now what we have is we have all 4 pieces together to get the total integration, remembering to add in that constant of integration here. Okay, so we did it by integration by parts and did that, and now we're going to be able to use kind of the table to help us do some of these integrations and simplify them down as we go. All right, so here we want to find the integral of ln of x, the quantity squared, dx. All right, so let's go look and see if we can find anything in the table that would help us with that. So I think it might be later because the ln's I think are at the end. Uh, Here it is. Ln of u to the n du. All right, so we're going to use that one. And so that's going to be our first one. But then what happens is we're just going to end up with the ln of u once we do that first time. Because remember, we have a squared. So if we have a 2, that's going to be a 1 here. So we're also going to have to use 49. So we're going to have to use 52 and 49 because after our first one, we go to 49. So this one was kind of a double whammy. So we're going to use on this one, we're going to use 52. Where's my pen go? There it is. Number 52 first, and then we're going to do number 49. Okay. All right, so first things first, 52 says we have the integral of ln of x squared dx, we're going to get x ln of x, the quantity squared, minus 2 times integral of ln of x dx. But now 49 says, okay, well, we can break this one up. And so if we bring this down, we have x ln of x quantity squared minus 2 times. Now this is x ln of x minus x. And then we have our constant of integration out there. Now, can we simplify? We might be able to. We could get rid of parentheses anyway. So that would be x ln of x, the quantity squared, minus 2x ln of x plus 2x plus c. And I think that's about as far as we can go as far as simplifying it down as much as possible. And so that then would be our integration using the table of both number 52 followed by the 49. Okay, so sometimes you're gonna have to do doubles to make it work, and that's okay. So that's just how some problems are going to work. All right, so let's stop there and we'll come back with one last example.